So I'm working on the OpenRoad portable fast charger, and my primary role in it is to design the DC to DC high power converter for interfacing between the battery and the car. Essentially what we're doing is we're taking a battery that can give us a certain amount of power, and we're taking a car that wants a certain amount of power, and we're bridging the gap between them, and that's the circuit that I'm designing. So we're able to take a neighborhood's worth of power, turn it on and off thousands of times a second, and then take it and put that into the car to get it to charge as fast as possible.
So the vision behind OpenRoad was to address a lot of the pain points we discovered ourselves in driving EVs. Once you take them seriously as automobiles, as a full-time driving vehicle, you discover certain pain points, and one of them is you're always a little bit lower on battery than you want. So the OpenRoad product is designed to be portable range booster in part, that you can always get an extra 25 miles in your car, wherever you are, from a device in your trunk. When starting a project like this, the biggest challenge is you don't know what you don't know. And so it was critical to talk with Dr. Taylor early on to figure out what's even possible in this space. What can we do, and what's at the outer edge of what would be almost impossible but not quite? What would be really cool to do? And that's how we came upon the basic specifications for the OpenRoad product. For us, the significance of partnering with an academic institution like Kettering is that there's a lot of really valuable knowledge sort of locked up in these places. For us, the exciting part is taking this and bringing it directly to market and working in a partnership in a way that I think wouldn't be as rapid and exciting and cutting edge if we did it in the usual way. When we first approached Kettering, we really didn't know what was possible. And we had a series of meetings with Dr. Taylor early on. And I was like things like, how fast can we get charged out of a portable device? Like, what can we put in a thing about this big, a luggage-sized device? Can you put a supercharger in a suitcase? And the answer was surprisingly yes. I mean, you have to worry about a specific high voltage and rapid battery discharge, but we worked through all this stuff and discovered that really cool stuff is possible once you tap the right store of knowledge and industrialize it.
Some of the challenges with this project are, one, the high current capability that needs to be delivered when the system is running at full power. Another challenge is the thermal considerations. Since we're running this system at such high power levels, everything, including the batteries, the circuit boards, the electronics, they'll all begin to heat up a little bit, and so we need to carefully manage that thermal energy. Another challenge that we're dealing with and kind of working through is just keeping an eye on maintaining high levels of safety. We've actually kind of been working on engineering some solutions specifically to protect and fuse all of the battery cells within the product. So the development work on this project will involve a couple of Kettering graduate students. We have one student actually who's going to be helping to design the high-power DC-DC circuitry, which is used to discharge the product and charge the electric vehicle battery. Another student's actually working on developing the battery pack itself, a circuit called the battery management system that goes along with it and protects it. We're all familiar with gas cans as a means to extend range of a vehicle that runs out of fuel. But there's not really a good equivalent for the electric vehicle market yet. So hopefully in a couple of years, more projects like this will start to take off, and this particular product hopefully can continue onwards.
We feel this product and products like this are important because the most disruptive trend of our time in industry is electrification. It's not just cars, it's motorcycles, it's riding mowers, golf carts. All these categories of things that are not electric now are going electric because they're simpler, they're faster, cheaper, better, and they'll need to charge these things and charge them in times and places that are currently not convenient. So the importance of moving charge around from place to place and delivering it quickly will grow ever more important every year from this point forward.